myself, Bardapurkar, Yogeshwari Mahavidyalaya, subject physics. Dear students, today in this lecture we will discuss the differential equation of linear S.H.M and its solutions. The differential equation of the linear S.H.M is represented by d2x by dt2 plus omega square x is equal to 0, where d2x by dt2 is the linear expression. This is second order differential equation of the linear expression. Omega is angular frequency of linear S.H.M, where omega is equal to root k by m. In this equation, k is force constant and m is the mass of the object for forming linear S.H.M. X is its displacement from the mean. This differential equation can be solved by integrating it. The results are called solutions. In order to integrate this equation, we have to rearrange this differential equation. So d2x by dt2 is d by dt of dx by dt, where dx by dt, rate of change of linear displacement with respect to time, is linear velocity. So we can write linear acceleration A is equal to dv by dt. So differential equation becomes dv by dt plus omega square x is equal to 0. Once again, rearranging the equation, dv by dx into dx by dt, multiplying and dividing by dx to this term dv by dt is equal to minus omega square x, or dx by dt, rate of change of linear displacement with respect to time, is taken as linear velocity. So equation becomes v dv is equal to minus omega square x dx. Integrating this equation, we can obtain v square by 2 is equal to minus omega square into x square by 2 plus c, where c is constant of integration. And its value can be found out by using the conditions in the linear S.H.M that whenever the displacement of the particle is equal to amplitude, that is when the particle is at either extreme position, the linear velocity of the particle in S.H.M will be 0. If we use this condition, we have c equal to a square omega square by 2. Using value of c in this equation, v square by 2 is equal to minus omega square x square by 2 plus c. We have equation for the velocity as v square by 2 is equal to omega square a square by 2 plus minus omega square x square by 2. So it becomes v square is equal to omega square in the bracket a square minus x square, or v equal to plus or minus omega in the square root a square minus x square. This is the first solution. First solution of the differential equation, and it represents the expression for the linear velocity of the particle. whenever the particle is at a distance x from the mean position. So this is velocity equation in terms of displacement, or it is displacement dependent expression for the velocity. That is, it is relation between v and x. This is first solution. This equation for the velocity can also be integrated to obtain the second equation. That is second solution. And this second solution represents the expression for displacement. So, taking positive value of the velocity v is equal to omega in the square root of a square minus x square. Rearranging the term v as dx by dt. Rate of change of linear displacement with respect to time is taken as linear velocity. So v is replaced by dx by dt is equal to omega in the square root a square minus x square. Or once again rearranging dx by square root of a square minus x square is equal to omega dt. Integrating this equation, we have sin inverse of x by t is equal to omega t plus alpha, or x by a we will use capital A for input. Since small a is used for the acceleration. X by capital A is equal to sin omega t plus alpha, or x is equal to a sin omega t plus alpha. So this is second equation, second solution of the differential equation. It represents the linear displacement of the particle from the mean position at the given instant t. In this equation, alpha is the constant of integration and its value depends upon the initial conditions. At t equal to 0, suppose the particles is at position x0. So using this condition, we can write x0 is equal to a sin in the bracket omega into 0 plus alpha. That is, x0 is equal to a sin alpha, or alpha equal to sin inverse of h0 by a. So it is quite clear that this angle alpha depends upon the initial condition of the motion. In this term, x represents the linear displacement of the particle from the mean position, a is the amplitude, and the term omega t plus alpha is called phase angle at given instant t, and alpha is called initial phase or epoch at t equal to 0. And the value of the alpha is given by alpha equal to sin inverse x0 by a. This is the second solution, x is equal to a sin omega t plus alpha, and this represents the equation of the displacement of the particle from the mean position. This is time dependent equation of the displacement, or displacement is time function of time, and it is sinusoidal function. So we have obtained two solutions of the differential equation. With these two solutions and the differential equation, equation, we have the relation between the acceleration and displacement as acceleration A is equal to minus omega square x. Second equation, velocity and x, which is v equal to omega in the square root a square minus x square. This is invariant. The velocity can be positive or velocity can be negative depending upon the motion of the object during the motion. And third equation, x and t, which is x equal to capital A sin omega t plus alpha. Now we discuss. We have already discussed the equation A is equal to minus omega square x. Now we will discuss this second equation between the velocity and the displacement of the particle. Displacement dependent on the velocity. Now, from this equation V is equal to omega in the square root of a square minus x square, it is quite clear that as x increases, the velocity V will decrease. So, when x is maximum, the velocity will decrease. X is equal to plus or minus a. Then V will be equal to V minimum, and its value is given by V minimum is equal to omega in the square root of a square minus a square. Whether the x is positive extreme, that is plus a, or minus a, the square will be always positive. So a square minus a square becomes 0 and V minimum is 0. So this is the first value of the linear velocity at either extreme points. This is the minimum value of the velocity possessed by the particle in linear S.H.M, and its value is 0. This value is possessed by the object whenever the object is situated at extreme position. Extreme position or positive extreme or negative extreme. So, whenever the particle in linear S.H.M is situated at either extreme position, the velocity will be 0. Now, once again, if x is minimum, then the velocity will have maximum. So, when x is equal to minimum, that is 0, whenever the particle at mean position, the V will be equal to V maximum. So, V maximum is equal to omega in the square root a square minus 0 square. That is V maximum is equal to a omega. At extreme position. So when the particle performing linear S.H.M is at mean position, will have maximum velocity, and this maximum velocity will have magnitude a omega. So these are the minimum and maximum values of the linear velocity of the particle in linear S.H.M. Now we will discuss the minimum and maximum values of the displacement. is equal to A sin omega t plus alpha. We can write at t equal to 0, say particle starts its S.H.M from the mean position, x is equal to 0. Then alpha will have 0. That is 0 by A is equal to sin omega into 0 plus alpha. So sin alpha is equal to 0, so it indicates alpha is 0. So whenever particle starts its motion from the mean position, the initial phase alpha will be 0. And if the particle starts its S.H.M from the positive extreme position, x is equal to plus A, then plus A is equal to A sin omega t plus alpha becomes plus A equal to A sin omega into 0 plus alpha. So sin alpha is equal to 5, that is plus 2. So alpha is equal to 5. Using this equation, x is equal to A sin omega t plus pi by 2, or x is equal to A cos omega t. This is the expression for the displacement of the particle when particle starts its S.H.M from the positive extreme position. If it starts from negative extreme, the equation becomes minus A. So it should be remembered as a point, MCQ point. So whenever particle starts its motion from the positive extreme position, the value of the initial phase alpha will be pi by 2 and equation will be represented as x is equal to A cos omega.